If you're a technician or a contractor that's already following industry best practices, then not much really needs to change in your day-to-day. However, there are some updates that we do need to be aware of as we transition to these A2L refrigerants.
Tony Gonzalez from Fieldpiece. How are you, my friend?
Clifton, the man, the myth, the legend, how are you?
I don't know about that, but I'm having a good time hanging out with you.
Absolutely.
We've been working on an A2L installation. We have a two-stage, high-efficiency, dual-fuel heat pump application. It is an A2L system, and so you've joined us to help talk about best practices and tools for working with an A2L system. Can you discuss a little bit with our audience what it means to be an A2L technician?
Yeah, so at a very high level, the good thing is if you're a technician or a contractor that's already following industry best practices, then not much really needs to change in your day-to-day. However, there are some updates that we do need to be aware of as we transition to these A2L refrigerants, right?
Agree.
So in terms of best practices, things that were previously recommended are now required.
Sure.
Like a nitrogen pressure test to confirm there's no leaks, pulling the proper vacuum. And in addition to that, there are updated regulations to make sure that the tools that we use in the field are also compatible with the new Class A2L refrigerants.
Exactly. And so we're going to be utilizing our A2L compatible products for this job. We're going to walk through some best practices and principles, and I encourage everyone to learn more. Fieldpiece has some fantastic resources on the A2L compatible tools. Tony, where can we find out more information about A2L compatible Fieldpiece tools?
So number one, you can go to fieldpiece.com.
Okay.
That is our website.
Yeah.
Follow us on social media at Fieldpiece Products are the best resources for that.
Fantastic. Thank you. Well, hello everyone. Thank you so much for joining us once again on Did You Know, the ESCO HVAC show. So, as you've seen, Tony and I, as well as Johnson Controls and Copeland, we spent some time doing a product installation and going over best practices with tools and techniques. And a lot of educators, and like myself, we get a little rusty over time, and it's good to be back in the field, right? Getting our hands dirty and making sure that we're staying up to date ourselves and implementing new products and tools and technology. So today, we're spending some time with our really good friend, Tony Gonzalez. How are you, sir?
I am wonderful. If I was any greater, I'd be you, Clifton.
Oh
So
my
I
gosh,
cannot
no.
complain.
And you got the beautiful weather out there in California. Yeah.
It is nice. Low 80s and no humidity. We cannot complain.
No, absolutely. So I'm actually going to be scorching here in a little bit, but it's going to be worth it because we're going to bring some quality education to you, right? So we've dedicated to talking about techniques and practices in this A2L transition and making sure we have all the right tools. But a lot of times, especially as educators and even contractors and technicians, sometimes we struggle with doing the best practices because maybe we didn't learn from a person who's been properly trained on things, right? Maybe we've watched a variety of videos, we've got a good idea, but we've never been through a formal class with like Fieldpiece on how we actually can do system commissionings. And it's so important to commission a system properly to know that it's actually going to perform the way that it was designed, the way that it was, selected, tested by the equipment manufacturers and third-party organizations like AHRI. So we're going to do a hands-on walkthrough today. Now remember, a little rusty here, so we're going to have some professional instruction along the way to make sure I'm doing things right. We're going to be drilling holes in furnaces, Tony. I mean, what can go wrong here?
Officially, we'll be installing test ports, I believe is the customer-friendly way when we're in their homes.
I seen a post on that and I thought, man, that is the way. Yeah, we are not drilling holes in anything. We are installing professional test ports. And some of them look really, really good. I know TEC has got some super cool little test port covers that actually, shows you that it is a test port for
I just saw that. Yeah, those are pretty cool.
They are. I just found them yesterday and I thought, man, I wish I would have found those earlier. I would have ordered some because they're a fantastic group. Hey, Kendrick, thanks for joining us. Glad that you're here. Everyone, let us know where you're joining in from. If you have any questions along the way, make sure to chime in. I'm going to be joining from my mobile device here in a minute, and so that I can go outside. We're actually going to do a full system connection outdoors as well as indoor. So we're going to take a look at the system performance, right? We're going to calculate the actual capacity of this system. Now, remember, so this is a 5-year-old house, right? So, my studio's here attached to the house. This system has been worked on many a times when I first moved into this place, because I had a 7-degree differential between first floor and second floor, whether it was summer, winter, and it was a nice home, right? And so along the way, I had asked about, hey, George, thanks for joining us from Western Kentucky. Along the way, I've asked a couple times about things that were being tested properly. And at one point, because remember, I'm playing dumb homeowner the whole time. I don't want anybody to know, hey, Paul, thanks for joining. I don't want anybody to know that I have an idea of what's going on here, because it's all under warranty and I can't touch the thing, right? And at one point along the way, I was like, hey, one of my buddies was saying that they had a problem with their ductwork, and the technician had measured some kind of pressure or static or something, and was able to determine how well the system was running. Has anything like that been done, or can it be done to the system? And immediately I was like, oh yeah, static pressure is, I've already checked it. It's good. It's a 1/2 inch, which is right where the manufacturer says it's supposed to be. And I'm like, oh, okay, cool. I'm glad that's so. So we're not going to talk about any contractors. I've removed all the stickers, even from the equipment, so that, we're just going to talk about a system and how we actually install things properly. Howard, that's such a good point. You bring this up, and I don't think it's stressed enough in the industry. And all the equipment manufacturers will, attest to this, that, a majority of the systems are not installed properly. They're not sized. And the biggest one is that 82% of components coming back to the manufacturers are no fault found. I know this system right here, right? I had a issue with it running in the heating mode, where it was going through some shutdowns and lockouts. And I had 6 different control boards put on this furnace. I had 3 gas valves. I had igniters 2 or 3 times. There was a lot of things that were just replaced, and I'm sure were sent back under warranty. That was the whole reason I wasn't touching this, is because it was still under warranty. So it's really about testing things properly. And tools have changed so much, Tony, even just in the last few years.
Yeah, the thing that modern technology, when it comes to tools, has provided, in some cases, it does allow us to do things more accurately and more than we've done before. But one of the biggest benefits, it allows us to take all the measurements that would take all day to measure in a short amount of time, right? Because when we're in the field, you're in the summertime, you don't have one job a day. Right. You might have 6, 7, 8 jobs a day. And you just can't spend 2 to 3 hours for every single job. So using modern tool technology allows us to not have to skip steps, to still take all the appropriate measurements we need to confirm proper operation of the equipment, just in a much faster manner and more accurately.
Exactly. And the things that we're going to do today are things that I've done in the past, some of which I had mechanical apparatuses, like tube manometers and client manometers and things that we won't even discuss because they're so ancient. And so Fieldpiece was just so gracious to be able to set us up with a set of the Job Link system, as well as additional tools that are all part of this ecosystem that Fieldpiece has developed to make you more efficient. And I encourage all of you to, learn these techniques, but also connect with Fieldpiece and make sure that you are teaching this as well in the classroom, because I'm telling you, it will save you so much time. And if we think about the technicians that we're preparing, these students coming through class, they know more about technology and apps than any of us educators do, right? Just because they've grown up with it. So we're going to walk you through the setup, and then I'm going to take a few minutes. I'm going to go outside. I'm going to connect to the outdoor unit. I'll take another little break, come inside, set up on the indoor unit. We'll show you some proper placement of pressure testing ports. And then we're actually going to dive into this app and look at everything that it can do. I mean, it's actually quite impressive. Aha, Professor Silberstein joining in here as well. All right, so let's start with a job link, Tony, and I'll go ahead and connect the tools in here before I take them outside, just so everyone knows, like, how do you even start these up, right? Where do we begin? Mm-hmm. So I'll go ahead and I'll grab my stand here. We're going to go ahead and go into HVAC. We're going to grab the Job Link app. I'm going to add in a separate camera feed for us as well, so that you all can see what I am seeing. And Oh, it's already in. I just need to bring it up front. Okay, so we're going to be diving into the Fieldpiece app. Oh, it looks like I need to reverse my camera real quick. And I'll bring that in. Oh, not that camera. Let's pick another one. Let's do.
Whoa! Did you get dizzy? That was a quick turn.
I was a quick turnaround, wasn't it? Boy, why is that? Oh, video setting. All right, let me hop in here and see. And now we're cooking. All right, and yeah, I think we will. Well, since I've got that set up on the countertop, let me zoom in here, see if I can't clean this up a little bit for us. Okay. All right, so we're going to start on the app. And so we're going to be doing a few things here, right? So we're going to be doing some of the things that you may already be comfortable with in the Fieldpiece tool selection, and we're going to add some that hopefully you've not used, and we're going to show you how those integrate. So Tony, let's start here. Where do you think we want to start?
So I think a very common question that we get that we can knock out from the very beginning is one of the nice things about the report that we print out at the end of this. It can be customized with the contractor's company logo. So like quickly from that screen to the right of Fieldpiece, there's a profile picture. Tap onto that. And now right there, you see your account information, but then scroll down a little bit and you'll see where it says company logo. See, so right now you have your ESCO logo on there. And so if anybody wanted to be able to customize their PDF report with their logo, all they do is go to that setting, tap it, opens up your camera roll or your camera, whatever you want. And then you can input your logo there. That's a quick and easy pro tip right there, right off the bat.
Yeah, that's an absolute must. Nothing better than some branded documentation for your customer. All right.
Absolutely.
So we're going to start connecting some tools. Where's the first place we want to begin?
Yeah, so we're just going to jump right into measurements. That'll take us right to the nitty gritty of what we're trying to do. Now, if you see along the top of the measurement screen, there are 6 icons, right? And it goes from a lightning bolt, which is where you would connect like your multimeter, the SC680, SC480 to take power measurements, electrical measurements, things like that. By default, you end up on the second tab, which looks like a thermometer, and that's where you would connect your job link probes or your S-man to measure your refrigerant pressure, temperature, superheat, subcooling. You would connect your psychrometers there to measure your return and supply temperatures, and also your static pressure manometers. You would also hook view the measurements coming from those tools on that second tab there, right? Now, the tab after that, which I call looks like a floppy disk. And so I would imagine everyone on this live stream knows what a floppy disk is. I'm not calling out anybody's age or anything, but
5 1/4.
That is a tab where we can view our vacuum in microns from the micron gauge. And under that, there's a new section for our brand new all-in-one refrigerant and combustible gas leak detector, the DRX3. So that can connect there, so you can mirror the screen of your leak detector also on your phone. And then also you can even document that it's found leaks into your report as well if you want to. And then at the bottom of that, there's a tightness test. So that's also relatively new, that you can use either your S-man digital manifold or your Joplin probes to perform, record, time, and document your nitrogen pressure test, right?
Absolutely.
And the nice thing is that it is temperature compensated. And so if there are changes in pressure due to temperature, the app will take that into consideration, calculate it to make sure that you get a more accurate pressure test, okay? And then now to finally wrap that up, the next icon looks like a scale. So obviously that's for your refrigerant scale. That's where you can document how much additional refrigerant you needed to charge into the system, because that's a very important thing to document and to keep track of, right? And then towards the end, you see a flame. That's where the combustion analyzer will connect to, so you can view the measurements coming from your combustion analyzer and even create a combustion report through the JobLink app as well. So it's categorized by those tabs, and we're just going to jump into that thermometer tab to start connecting some of these tools.
Okay. Yeah. No, you're right, Todd. It's phenomenal the way our industry is advanced. And so I know many educators, they're getting exposed to this and asked to teach on this, and they may have not ever been introduced. And so that's what we're here to do. We're walking you through the entire thing. Okay. So we're going to start here then. All right. So I'll just start where we want to begin.
So we want to begin on, I mean, to me, I always start with the big why, right? And so why are we even doing this? Well,
Yeah.
in order to properly commission a system and confirm that we have proper operation, we got to look at three things. We got to look at the airflow, we got to look at the refrigerant charge, and we got to make sure all the electrical components are wired correctly and that we have power in the right spots where we need the power, right?
Sure.
And so we will start there on what the JobLink system is designed to do, right? It is designed to be able to, let's look at the airflow, let's look at the refrigerant charge, and let's look at the electrical parameters. And the nice thing is it's all at the same time, right? So even if indoor or outdoor conditions were to change, we will see all those changes happening in real time so that we can get a quicker, more accurate diagnosis of how the system is performing.
You bet. All right, so we'll go ahead and connect those in here, and then I'll back out of the app, leave it in the background. I'll bring my camera on. We'll go out and do some actual physical connections. So what do you think then? Since we're in our manometer, go ahead and start in there.
Yep. Let's take out the manometers. And so the JobLink wireless manometers don't look like your traditional manometer, right? They are two little single port probes that function like a dual port manometer with the JobLink app. So you have a handy magnet on the back of the probe body and on the base of that static pressure probe. Now, those static pressure probes are key because it really helps us dial in and get a more accurate reading of the static pressure, right? Versus just sticking our tube into the ductwork. We got to be very careful that we're getting air going directly across the opening of our tube versus at any direction in. So having that static pressure probe allows us to very easily ensure that we have air going across the holes in the probe and not directly into the hole, which would mess with the accuracy of our static pressure reading.
Okay.
And so first you would power those on. So you hold them for about a second until you see green, then you let go. And if they're blinking, that means you are in normal operation mode and we're ready to sync. If you held it too long, you're going to get a solid green, and that means you're in data logging mode, and you don't want to do that, so turn it off and try it again.
Okay.
And so it looks like you've already previously synced those manometers because the measurements instantly came up. But if you had not, it would say link tool there, and then you would tap on that. So you could tap on any one of those numbers on that screen right there for the manometers. And then there, it'll display to you any manometer that is set to P1. So on the back of those probes, you have a switch so that the app knows, is this my P1 tool or my P2 tool? And so the app is smart enough to know that if I tapped on the P1 container, it's only going to show me manometers that are set to P1 so that I don't reverse the reading, right? And that goes for all those tools. So one is set to P1, one is set to P2. And if it's powered on within range, it's going to show there. And then you just click on what would be a black circle to make it a blue check mark.
Right.
And then that's when you get measurements on your screen. And once you connect it once, the JobLink app is going to remember the last tool that you linked to that particular cell so that you don't have to do that linking every single time.
Yeah. You know, another thing that was very ingenious that I love how you put on these, when you make those switches, they actually change the color of it. So the P1 is actually now blue and my P2 is red. For me, I like low pressure on my lower, my blue, and high pressure on my red. So I think of that as a negative pressure on one and positive pressure on two. Just kind of way I think about it.
Yep, absolutely.
All right, so we got that one. All right, let's move on then.
Okay, so now we have the digital psychrometers. Okay, and so those are designed to measure temperature and humidity and then calculate in the app dry bulb, wet bulb, and enthalpy. And we're going to sync those to the air or link those to the air side container. So if you scroll down a little bit, you'll see to where it says air side. And right there are two columns. There's a red return column and a blue topped supply column. So we're going to link these the exact same way, right? On the back of those probes, there's a switch. One says one side says return, the other side says supply. So you just power them on, and then the app knows which one's which. And if you've already synced or linked them up, then they will just automatically display there. So there you go. Boom. So now we have from the top to the bottom, we have dry bulb, we have wet bulb, humidity, dew point, and enthalpy. And then under that, we have a delta T, our supply, our return minus our supply temperature.
Absolutely.
Easy
Okay.
peasy.
All right. Easy peasy. All right. Let's just keep on going. Boy, we got all sorts of goodies in here.
Yep. So now for airflow, we're going to be looking at static pressures, and with the psychrometers, we're going to be looking at heat transfer across that coil, which is key to understanding performance.
Absolutely. All right.
So now we'll move into the refrigerant side of the system. And so now we have there two columns, right? We have suction blue and liquid red. So those are the pressure probes. Same, there's a switch on the back that says liquid or suction, and then the color matches, right? If you have it on suction, it's blue. If you have it on liquid, it's red. So we'll power them on. And if you're blinking, then you're good. And then, so the high side is popped in, and the low side is popped in. Now we see zeros, obviously, because we're not measuring any
pressure. Okay. All right.
Oh, yeah. And then those are the JobLink pipe clamps. So now those are designed to measure pipe temperature. And same, they have a switch. One says liquid, one says suction. Now those are particular unique pipe clamps in that they have a patented sensor that's called rapid rail. Now rapid rail is designed to give you a accurate temperature within plus or minus 1 degree on the pipe that is not influenced by being in direct sunlight or being in wind or moisture on the pipe, because it uses the conductive copper of the pipe to close the temperature circuit to get a quicker, more accurate reading. And so that would, you just power them on, same way, press and hold the power button, and they will link up.
Okay. One of the questions or comments that came in from Todd was, if there is a need for zeroing any of the tools, is there a easy means for zeroing?
Yeah, so when we go to the pressure probes, when you turn on the JobLink pressure probes, they do both an atmospheric zero and an elevation adjustment. So there's PSIA sensors in there, and they will adjust to atmosphere and measure atmospheric pressure, but display gauge pressure on the screen. And they also have a barometer built in, so they adjust for elevation. So you can power them on and then connect them to the system. And then on the manometers, we can get to the zeroing when we start to hook those up to the system.
Okay. All right. I'm going to go ahead and reload these, and then we should just have one additional tool to connect, and then we should be ready to go connect this thing in, see what we got.
See, right, what's that last one we got there?
Last one was going to be our meter.
The meter. Okay. So, pop quiz. Does everybody remember which tab do we go to connect our meter? See who's listening.
Where's the timer?
Basically, we're going to check if Clifton was listening. Yes, success.
All right.
The lightning bolt.
And so we've got both available here. We've got the 460 or 480 and the 680. 480 is a tad bit smaller. I'm going to go ahead and take that one with me for right now. All right. So let's just go ahead and
yeah. So
do from here.
So on the SC480, we're going to power it on to any switch position, but we can start on volts. And then there's a button that's labeled wireless. So we will press the wireless button. And on the top right of the screen, you want to confirm that you see the wireless icon and it says on. And so if you do, then now the app is, so yep, there you go. On the top right, you see the wireless icon. And then since you've already linked it, we're already seeing the 0 volt reading on the screen of your JobLink app. Now on the meter, if you press the select button right in the middle, you'll also enable the amps. And on the top display, just press the select button. Yep. Nice. And so now we have both volts and amps, and now we'll see both volts and amps on the JobLink app.
Okay.
So it looks like we're locked and loaded.
I think we're about ready here. Yeah. So let's go ahead and gear up, and I'm going to run outside. We'll get some things connected, see where we're at. So I might have you just kind of walk through, some of the things we're looking for along the way. Look at you already getting set too.
Best buddies.
I'm telling you, man, I enjoy working with you so much. We have a lot of fun. All right, safety glasses, gloves. I'm gonna go ahead and I'll take my stand, my drill. What I'm gonna do is I'm going to back out of here, keep it live, and then I'm going to join this conversation. So I want to make sure that I can join before we go out there.
Got to make sure.
Yeah,
you don't want to leave me hanging here by myself.
I don't. You'll be teaching a whole class, although I'm sure you'd have no problem teaching a whole class by yourself. Another half hour, you can shoot right on through that. All right.
That's it. And that is feedback. Don't worry, that is not annoying at all. It didn't hurt anybody's ears. So
that's right. We know that it connects, and I can cut that out later and post edit. All right. Are you ready? All right. You ready for this, Kendrick? Yeah. All right. So I'm going to head outside, and I'm going to go ahead and leave this screen up. So, Tony, I'll take my earbuds with me, too, just to make sure that I can reconnect. And then I'll double check when I get outside and make sure that I've got audio connection. And then I'll see you all here in a few minutes.
Okay. So... all right. So wait, Clifton, just confirm. Can you hear me talk while you're transitioning?
You
cannot, which means I can say whatever I want, and with pure immunity. No. Okay. So really what we're talking about here in terms of the contractor, right? You know, the way that I think about issues and the way Fieldpiece thinks about issues is what are the problems that contractors have, right? And then we develop a solution to solve those problems. So here we're talking about commissioning, right? Okay, that's cool, but what is the problem, right? Always start with the big why. Now, the problem is partly what Howard put up on the screen, right? Was that there's a very large percentage of HVAC equipment that is just not installed properly, right? And that causes a whole slew of problems as far as homeowners not being comfortable, energy costs being high, premature failure of equipment, and it's bad news for everybody. Nobody wins in that scenario. So what is the cause of that, right? Like there's never really one cause. And so there's multiple causes. Like one of them has to do with, you know, the lack of knowledge and the want to get training on the equipment, right? Like how to properly install this equipment. So I at least know how to do a good job. And then after that, right? Like how do we confirm and prove that we actually did a good job, right? You know, back in the day, we used to use that advanced tool called the handometer, right? We would grab that beer can coal suction line. We would put our hand up to the supply. Yep, everything looks good, Mr. Customer, right? But there was very little accountability and documentation to what was being done. So what we're talking about with modern technology like the JobLink system is to help address that aspect of not only being able to verify the performance of the system by way of measurements and confirmation of airflow, refrigerant charge, and power and things like that, but the ability to document it and to have proof that tests were done properly, so that we have kind of like a CYA report of, yes, pressures and temperatures were good. Airflow was good, right? Static pressures were where they needed to be. Heat transfer across the coil was where it should have been. But in addition to that, the JobLink system in this report, we can document tasks of an install. So starting with that nitrogen pressure test, right? In that report, it'll document, right, what the pressure was set to, what it held at, for how long the test was ran, and then what were the results. And then after that, what is the next step? Well, let's pull a vacuum. Same thing. In this report, we can document what we pulled the vacuum to, what the rise was, how long we let it rise for decay. That's all part of our test. And then if we had to add, or that's all part of our report. And then after if we need to add additional refrigerant, we can use the JobLink system again to document how many pounds or ounces we added to the system. That's all part of our report. So all of these steps not only have the ability to be tracked on the job site, but also documented and having proof. So if I'm a service manager or I'm a contractor, I'm going to want to know that, my people are not only performing these tasks in the field, but that they're being passed, right? Because then that, as a contractor, will provide a better customer or a better service to my customer, increasing their customer performance, increasing their customer satisfaction, which in turn increases customer loyalty and just generates more leads and more business. And then on the flip side, if we properly commission and verify the performance of the system, we greatly reduce the likelihood of a callback or any issues resulting from the install. So from the contractor perspective, it's a business play, right? Increase my revenue by increased customer satisfaction and loyalty, doing a job well done, and then lowering my expenses by dropping down dramatically the cost of a callback. And so those are the problems that we're setting out to solve for the contractor. And now Clifton is ready. I talked about the why and the what. Clifton's about to get to the how on how we actually do those things.
Yeah, this is how an old man gets worn out running back and forth. That's how this is.
Did you forget something?
Yeah. Had to get the.
There we go.
It actually had the mechanical caps versus the O-ring caps, so I had to run and grab a wrench real quick. So, all right. So we're going to begin. We're going to go ahead and kill power to this system, right? Before we get started, so I'm going to pull our disconnect. Let me flip camera, and we'll actually get on the unit itself. Let's do. Let me try the other camera. Got a couple options here. All right, that's probably our best perspective, somewhere in that ballpark. Okay, now let's see. I'll bring that up a little bit for us too. Okay, so let me get even better on that one, Tony. Okay, so let's begin on this thing. So first thing we're going to do, all right, we just connected our power. Let's go ahead and get this cover off. Since we're going to be doing electrical as well, all right?
Yep.
So let's go ahead and, just for sake, let's go ahead and start with power, right?
Okay.
Now, are we going to be measuring voltage as well as amperage on this?
So it depends on what you want to do. So if you want to measure watts, then yes, we will be doing both volts and power. So we would turn the meter onto the W, which is like the 11 o'clock switch position.
Yep.
And then we want to make sure that the wireless is turned on the meter, because I believe it defaults to off. And
wireless
so now
is on.
Yep. And so now, in order to measure that watts in real time, you want to connect those alligator leads to, I'm assuming that's single phase.
Single phase.
To your
L1.
L1, L2 terminals going in, and then wrap that meter around either L1 or L2 for the amps. It doesn't really matter for this particular test.
Okay. I'm going to sneak around here real quick. Hopefully I'm not interfering with the picture too much. Well, this is the reason I wanted to kill power. Anytime we're making these connections, we're working with some potential dangerous situations. All right. So hopefully that is readable enough for us now. All right. So we got power connected. So let's go ahead and move to our refrigerant side. All right. So we still have both of our meters running. So we're going to go ahead and connect onto our standard lines. And I'll put the high side on the high side. And I love that they are very minimal release of refrigerant when connecting. I'll move to this side to connect our other.
Yep,
All
so
right.
that'll give us the high side pressure and the low side pressure.
Now we're going to grab our temperature clamps. And I'm going to simply look on, all right, liquid on this one. So that one will go on my liquid. What type of a distance away from our service valves? Is there any?
So, I mean, not really. You generally want to be in the vicinity of our service valves. One of the nice thing about that sensor is that you can put it on an uneven part of the pipe or on a brazed part of the pipe if that's the only access you have, because there's a bunch of insulation, and if you get a single beep with a blinking green light, then you have a closed circuit and you'll get an accurate temperature. It gives you more flexibility to where you can place the probe.
Yeah, definitely. Okay, so we've got everything connected now. So I'm going to go back to this facing camera. So we've got our meter connected. We've got our pressure sensors, our temperature sensors. I'm going to reapply our disconnect. And we're going to head inside. And I'll take the rest of my tools with me. All right, I'm going to go ahead and shut my camera feed off for just a minute. I'm going to run inside. I'll get set up upstairs at the furnace. So I'll let you critique my work for a couple minutes.
We'll need more than a couple minutes probably. No, I'm just kidding, Clifton. So yeah, so far what Clifton has done is he has attached the meter so we can measure power in kilowatts of the system, and connected the JobLink pressure probes at the high and low side of the system to measure both the pressures and the temperatures. Now, one piece of feedback that contractors like in regards to having the ability to measure kilowatts is, let's say that they're on a maintenance call, and the first thing that they would do is they would fire up the system and take that kilowatt reading, right? And then they go ahead and perform their typical maintenance steps, clean stuff, make sure that airflow is set correctly, refrigerant charge, all that stuff. And then at the end of the job, take another kilowatt reading. So they have a before and an after. And so now they have an additional data point to show the customer the value that they've added and how their system is running either more efficiently, but also that it is providing a higher level of comfort for their technician. And so contractors really like that aspect of how to use the power as well.
Yeah, absolutely. All right. I'm going to go ahead and extend some legs. We'll take a look at this system and find our ideal location. Okay. Flip things around.
What are we starting with? Psychrometers or manometers?
Let's go ahead and that's about as close as I can get. That's not too bad. All right, let's go ahead and start with our psychrometers.
Okay.
Okay.
So with the psychrometers, we're looking to measure return air properties and supply air properties to basically understand heat transfer that is happening at the coil, right? We would want to get, as a general rule of thumb, as near to the indoor equipment as we can, both on the return or the supply side, or in the real world, just get as close as we can to either one to truly understand what's going on at the coil.
Okay. So what do you think on the return plenum before the filter?
Yes, that is a good spot for that.
And so for all of this, we're actually going to be using a 3/8 bit with a stop collar, so that just in case there was something behind our metal, we're not going too far through. So I'm gonna go ahead and use this existing hole, and I'm gonna open it up a little bit. Okay.
That's a nice test port.
Yeah, so that should give us enough opening. And we're going to verify, because remember, our probes are, I'm going to use blue for my low or my return side. Okay.
So return side would be red.
Oh, yep.
Yep. Return would be red. And the idea is there, return side is hotter than supply side in cooling mode.
Yep, makes sense. All right, and I went ahead and used my magnet on that. Now, I have two options on this particular piece of equipment. Let me frame this up a little bit, right? So I've got a coil, which I could come through very high away from my coil, or I've got some ductboard in the very top, which is right above my coil. So, what do we think? I think I feel safer on our ductboard on this one.
Yep, probably.
And look, we actually did have a technician measuring temperature.
There we go. Look at that.
Being a technician is we tend to find some extra components along the way. All right. Let me see.
Easter eggs.
That's right. So I do not have that screwdriver with me, so I'm going to use this existing hole, and I'll use my newly found knife, we're going to call it. And so we're going to utilize this access above our coil.
Yeah.
And we're now inserted about 3
Yep.
inches or so.
Very good.
Okay. Can we see where it's at? Not very well. Okay,
I can
guess what's
see
up
it
in there.
if you look hard enough.
Okay, so now let's go ahead and move over to the part that everybody's been waiting for. Let's make some holes. Or the part I've been waiting for anyhow.
Dun dun dun.
Okay.
Test ports.
Let's do some test ports. Now, we know that we need to be measuring the pressure, the external pressure on the piece of appliance, right? Gas furnace.
Mm-hmm.
We don't know. We don't know what filter assembly it's going to be installed with. We don't know what coil it's going to be installed with. So we're really looking at the pressure introduced across the blower, which means I need to be between my filter and my blower, correct?
Yep, absolutely.
And then I need to be between my blower and my coil, correct?
Yep. And a general rule of thumb,
Yeah.
and a general rule of thumb, because to your point, those test port locations differ if you just had an air handler versus that furnace versus a package unit. So the general rule of thumb is you measure the pressure directly before and after what came inside the box, right? And in that particular case, that furnace, the coil didn't come in the box, nor did the filter, right? And so when the manufacturer set that specification in the lab, to your point, they didn't know what filter was being used. They're not going to know what coil. They're just speccing pressure external to their box, and in this case, it's the furnace.
And afterwards, in the video descriptions, I'll put a link to an NCI PDF that is actually listed on Energy Star for best locations to be able to take a variety of different pressure measures across different pieces of equipment. So with this particular one, we're actually going to have to drill into the cavity of this furnace. Now, do we have any best recommendations for a good place to do that?
Repeat that one more time. I got distracted by a squirrel.
Oh, that's all right. So for the ports that we're going to be installing on our furnace, let's think of our best locations to do that. I'm going to need to be in my return side, hopefully close to the inlet to my blower wheel, right? This particular one, I know my motor's on the right. I have open access on the left. I've already removed the covers. I'm not going to take that off just for sake of saving some time. So I know that I'm going to be on this left side. It's my only one, really, besides a small location over on the right. And I'm just going to come up off from that filter assembly 2 or 3 inches. And there is some instructions on that. ASHRAE has a manual. I'll try to get a link for where those pressure readings are tested from. But for our purposes, we need to be in that airflow coming into that blower housing. That'd be correct?
Yes.
Okay, so I'm going to go a couple inches up from the bottom, close to my inlet of my blower housing. One, and then this is a condensing furnace, so I know that I need to be away from my heat exchanger, right? And I need to be very close to my airflow itself. So a lot of technicians will install these at the front or the very back of that vestibule, and I know where the coil location is on this particular one. Do you have any best recommendations before I do drill a hole?
Do not puncture anything on the inside.
That sounds like a great piece of advice. So I'm going to go to the rear of my cavity. All right. Okay, so now I have 2 holes drilled, and I'm just down to my 2 components. I've got my blue, which is going to be my P1, and I've got my red that is my P2. So let's talk about the location of the probe that is going to be on our return side. Which one will we use for that?
Yeah, so we can just go, I mean, at the end of the day, where you put P1 or P2 doesn't matter, but for sake of continuity, let's put P1 on the bottom side and we'll put P2 on the top side. Now, the static pressure probe, the best practice is you'll notice that it's L-shaped, and you generally want to point that L or that probe end into the direction of the airflow. So it looks like you have an upflow appliance there. So generally best practice is to point that thing down. So, but before you insert it into the test port, you want to zero out the manometer, because manometer is measuring pressure relative to ambient pressure. And so you want to zero it out. And so how you zero it out with the Jobling probe is while it's on, just quickly press and release the power button, and you'll get 3 blinking blue lights indicating to you that you have zeroed the probe. And then once you have that, you're ready to insert it into the test port. Just a quick press and release. Don't even hold it for any amount of time.
Oh, there we go.
There you go. Boom.
Cool.
And so now you're ready to insert your probe, and the base of that probe is magnetic, and on the back there's a red arrow that helps you point the probe in the direction that you want it to be pointed. Okay. And then the same thing for the P2 side. We want to zero it out before inserting it into the test port. And then insert and point into the direction of the airflow. Now, what's nice about that particular design is you don't have to really mess with 5 or 6 foot tubes on either side that can get tangled or clipped or bent somewhere. It's very short tubing that gives you much more versatility to place it in the right spot.
Okay, so now that we've got everything connected, I think I'll go turn the thermostat down to make sure that it kicks back on, and then I'll head back out to the studio. I'll see if I can pull up our app and find out what we got.
Let's do it. Yeah, so again, so now on the air side, what we're checking to confirm airflow is we're using the 2 cycrometers to measure return air properties and supply air properties, looking at delta T, but just overall, right? What we're trying to confirm is the coil absorbing the correct amount of heat, right? Because we don't want it absorbing too little, which is going to result in a hotter than desired space, but we also don't want it to absorb too much heat, because then that's going to cause issues on the other end of the refrigerant cycle, and so it's got to be just right. And then also we're checking the static pressures to ensure that the equipment is not being exposed to too high of pressures, so that it still works under its the way that it was meant to work in the lab, so it can be efficient and provide the most comfort to the customer. Okay, so
did I go too long?
Nope, we're good. We got P1, we got P2.
Okay, they're starting to enter. Hey, look at that.
All right. Now here's a quiz. So right now on the refrigerant side, we see pressures and we see temperatures, but I don't see any saturation temperatures and I don't see any super subcooling. What could we be missing here?
That's a great question. Are you getting my audio, Tony?
I am getting your audio. Yep.
Okay. All right.
And so we have to remember that saturation temperatures are relative to the refrigerant type. So if we do not tell it what the refrigerant type is, it has no way to look up what the bubble and the dew points are. So let's go ahead and on the bottom of the suction column that says refrigerant type and it says select. So there we have a bunch of options to choose from. There's over 70 different refrigerants, including the new Class A2O refrigerants. But at the very top, you have a recently used section that is just going to populate with the refrigerants that you most commonly use. So what refrigerant type is your system, Clifton?
This is an R410A unit.
R410A. So we're going to select R410A. And now you'll see we populate saturations. And we got superheat on the left and subcooling on the right.
Okay. Very intriguing. So now it just started, so we'll give it a few minutes to balance out. Now, do we have any questions while we're starting to get things set into place? Man, this is perfect timing. We're about 10 minutes till time we can actually look through it. We can ask questions along the way. A-Team Adam joining us. Question came in from A-Team Adam. Are we concerned with picking up radiant cooling since you're measuring the supply air properties within the line of sight of the evaporator coil? I know for mine, we have very limited access. So I've actually only got about 6 inches of ductboard above that coil. Not an ideal application in this home, right? This is a 2-story home. It's about 3,200 square feet. It's got about 1,600 square foot of garage space. And it is an upflow installation on the second floor. So this one's been quite the interesting scenario.
Okay. Yeah, and in the field, there's that balance of being too close, being too far. Like if we're too far away, then the temperature then the measurement can be affected by issues with the ductwork, right? Either static pressures or leakages, which isn't a true reflection of what's going on at the coil. So in the field, the technicians got to use their best judgment and just try to get in the best place.
Yeah, absolutely. And I said, and I'll add some links to that. I'll actually look for that here in just a second. I'll put that into our message notes for the link to that other downloadable PDF with a variety of different equipment applications. All right. So and I know we're going to have a significant amount of heat on this thing. So it was off for a little bit of time while I was getting rebalanced. So let's talk about a report. I know Paul mentioned one of the things, and I agree, Paul, this is the beauty of doing a full report. Is now we have not just the commissioning report, but now we have a continual operational report every time that we connect on this system. So, I mean, we took 30 minutes-ish, 25, somewhere in that ballpark. But you got to remember, I was huffing it, running back and forth, getting tools along the way. So in reality, yeah, we're about 15 minutes for a full connection. 15 minutes to know exactly how well a system is performing. That's pretty significant. And there's a lot of heat load. So temperature today, it's like 96 with a heat index of 118 degrees. And so as I was coming in and out of that front door, there's a lot of heat that was just getting pulled into that main return that's in that area.
Doesn't sound fun at all.
No, I'm glad that we got that part up and running. All right, so let's kind of take a look at some of the reporting so that we know what we're going to see out of a scenario like this.
Yeah, for sure. So, would you? Is this where you want me to share the report, or are you going to pull it up on the phone? How do you want to go? How to do that?
If you don't mind, and there's a couple of things that I just want to look at too, like on my air side.
Mm-hmm.
It's really curious.
So it looks like our delta T was, say, about 17.
Mm-hmm, about 17 degrees.
Okay, now one thing that's nice. Okay, so yeah, so now we have. Okay, if you scroll down to the bottom, do you have the airside diagnostics turned on? A little bit higher. A little bit higher. Okay, airside diagnostics, perfect. So when we look at the air at the indoor unit, like one of the measures that we use is delta T, right? And an industry, rule of thumb, we're looking about 18 to 20 delta T. However, that's not end all be all, because based on ambient conditions and conditions of that day, it is very possible that a 20-degree split is just not achievable, but that's not an indication that the system is that there's an issue with the system. So the Joplin gap does a calculation. It's called total external, I'm sorry.
It's okay.
Target evaporator exit temperature.
Yes.
That's just a long-winded of saying it calculates what the supply dry bulb air temperature should be based on the return side air properties. And so in this case, you see that the calculated target of your supply air is what? That says 57 point something.
0.2. Mm-hmm.
And your actual is 57. 50. So is that what it says? 57?
50.
I can't really see it.
So 50, yeah, 58 dry bulb and a 57.2 target dry bulb. So
okay,
less than a degree.
So you're within plus or minus 1, which means that you have pretty good transfer at that coil going on right now.
Absolutely. I really like the amount of diagnostics that you're starting to add into this. Very cool. All right. I want to look at our power side before we hop out of here. Oh, it must have disconnected on me. So
there we go.
That's the beauty. We can actually do data logging now, and we can also start calculating capacity.
So we got, it looks like we got 2.8 kilowatts going on right there.
Yeah, so this is a 3-ton 14 SEER unit. So I'm not surprised. Okay, so what can we look at? What can we determine from the data?
If you go back to the thermometer, we can quickly show how to do the capacity and all that. So the air side capacity is that container right there.
Mm-hmm.
And so it needs the measurements coming from the psychrometers because it looks at delta T to measure capacity,
Mm-hmm.
and it needs a CFM value. So for sake of time, we can just estimate what the CFM is of that piece of equipment. So you said it was 3 ton.
Yeah, it's a constant torque set at about 1250.
Okay, so let's insert 1250 in there. And so now we have a real-time BTU cooling capacity.
Look at that.
Right there. And now if we want to turn that into efficiency, go back into the lightning bolt. And yeah, that's weird. And so now to do an efficiency test, let's press the lightning bolt that's under the numbers. And that starts our power and efficiency test. So tap that to single phase. And right now you have the meter on L1, L2 measuring volts and on amps on L1. So we'll go ahead and press log because that's what that first row is asking for. Log button above at the top.
Oh, sorry.
Yep. Oh, you know what? We don't want to be on power. We want to be on volts and amps to run this test. So, but if the meter was on volts and amps, then we would just put those in there and then the app would just calculate automatically what the EER and the SEER is so that you get system efficiency in addition to that.
Love it. I think I'll pass on that one. I'll switch it after the show.
I don't want you huffing and puffing. Yeah, we're not going to do that anymore.
I'll capture it afterwards, though, and I'll throw it in as an edited video so people can see what the actual rating is, because I'll be curious myself. But it's amazing that we're actually calculating that, right? So 34.5 on a 36,000 BTU system. Sounds like it's actually doing a pretty decent job.
Yep. Okay. So now so now we're monitoring the airflow, the refrigerant charge, right? We saw superheat, subcooling. We saw delta T. If we look at the static pressures, we saw that you were approaching 1 on the static pressure side. So at the very top of the screen.
Yeah, that's a ½ inch, Tony. That's what's on this thing,
right? I already checked that. It was a ½ inch. Trust me. So this type of technology requires some accountability and show me the receipts. And so this is very, very good. So now,
amazing tool.
So we've connected all the tools. We're viewing all the measurements. Let's go ahead and wrap up the job with a report. So at the very bottom right, you see that yellow button with the 3 black dots. We tap on it, and then we tap on Create PDF. Now, in Create PDF, it pops up an open text box. Do I want to add notes to this report? And so this is like a free type for the contractor to put whatever note they want. A lot of them put customer information, right? Maybe their address, maybe their name. For here, we could put super cool guest on the ESCO show, right? Whatever,
exactly
something random like that. And then you press create, and it generates and previews what your PDF is going to look like. And so since you already put your logo into the app, like we showed from the beginning, you have your logo on the top of that report. And then directly under that, we have organized by their category. Air side measurements are all grouped together in their container, refrigerant side, and then the electrical, static pressure, right? So all the measurements coming from the tools will just populate into that report. And to the previous comment of, it's like a history. It could be like your Carfax for that piece of equipment, right? You could have the history of measurements that were taken and how the system was performing. And then if you were actually performing the install that day, you would also add containers here for, I passed my nitrogen test. I pulled a good vacuum. I added additional charge by weight.
All calculated.
Right? So
and documented.
It's all calculated. It's all documented and verified that these tasks were performed and they passed, right? So, imagine if you have a warranty for a compressor. Don't you think you would have a lot more clout with the OEM if you had a report showing, hey, everything was good at the time that this thing was installed, right? So there are so many benefits of just having documentation of the job that was done for the contractor side, for the warranty side, even for the customer's peace of mind side. it's just a win-win for everybody.
I absolutely love it. And to think that we've went this far in such a short period of time, because I've used the JobLink tools before, but not in this capacity. I mean, this is just absolutely insane.
And then from here, this report can be shared, right? It could be emailed, it could be text messaged, it could be sent up to if you have a Google Cloud. Also, if you're a contractor on, let's say, like Service Titan, and you use Service Titan Mobile on your mobile device, when you press the share button, the Service Titan mobile app will show up as an app you can share this report to.
And
you tap on it, you would tap on the Service Titan mobile button to share it. It'll prompt you to put in what is the work order number of that job, and you just press OK, and then that PDF gets sent into the Service Titan platform associated to that work order number. And that's so crazy. Now they have the receipts of everything that's on that job.
I mean, it's just amazing what Fieldpiece has done with technology. I sit in on some very high level meetings on a potential for having a connected commissioning for new systems, right? A report that would be utilized for energy companies, in particularly utilities, as to was this system performing the way it was designed so the person can acquire the rebate that they're looking for. And here it is, already ahead of its time.
So to wrap up, a couple of questions that were always asked: do I have to pay for any of this functionality that I'm doing? All the functionality that you have seen on this show, as far as the measurements, the connections, the calculations, the reporting, the sharing, all of that is on the free side of the JobLink app. Now, there is a paid side that adds other features like cloud storage, customer files. So if that is useful to your workflow in your business, then there is that option there. There's also an option that's called the live look-in. So if you have a less experienced technician in the field and they're using all these tools the exact same way that Clifton just did, they can call someone from their company that has the JobLink app, and then that person from the office can view live what that technician is seeing in the field, so that they're talking one-to-one on the phone about like what's the issue going on. And so those are some of the features that are on the JobLink Pro side of the app. But everything we've covered here is on the free side of the app to get to that commissioner report at the end of the job.
That is absolutely insane. This should be in the hands of every educator, every contractor, every technician. I couldn't be more of an advocate for what you have done with this. I am absolutely thrilled. In 15 minutes, I could have showed my contractor what they were missing.
Yeah, and so for all the educators, you can reach out to me at Fieldpiece, and we can set you up with your school version of your JobLink account, and then you can get access to those other features as well without having to pay for them. So we can help set that up for you so that you can help train your students. And what's nice about these tools from the teaching perspective is that one set of tools that Clifton hooked up, multiple phones can connect and view the measurements from those tools. So it's not a one-to-one. So imagine you were in the classroom and you have that one set of JobLink probes on your trainer equipment. All of your students can be linking to those exact same tools at the same time, so that everyone's looking at the same measurements at the same time, generating reports. So the way that the wireless works also lends itself greatly to the classroom, so that we all know your students are always on their phones, and now this gives them an engaging, productive way to be using their phones in the classroom that'll just increase their attention, their engagement to what we're doing here.
I couldn't ask for a better tool in the classroom. I mean, just imagine connecting this onto that piece of equipment and going, okay, Tommy, what happens when we restrict airflow on the return side? And you have an immediate quiz in the classroom. And then so you send someone over to actually do that in the classroom, and you're monitoring and watching it live. Every student.
Yep. You all see it.
Just take my money. All right. Any questions from anyone? I hope you learned a lot today. I hope we were able to simply walk through the process of getting everything opened, connected, and getting you into a place where you can be comfortable teaching and using the Fieldpiece JobLink to do proper commissionings and equipment servicing. Tony Gonzalez and the entire Fieldpiece group we are just absolutely honored to be associated with you as a premier educational partner.
But then the pleasure is all mine. It's it's all ours. At a great time in Bargersville, I said it correctly.
Yes.
And doing that project over there, and just everything that we do. We love the mission of ESCO. We also are looking at ways, I know myself particularly, how do we help address this labor gap, skills gap we have in the industry? And if we're all pulling from the same end of the rope, we can get some progress here.
I agree. All right. Make sure you all connect with Fieldpiece, get tied into the amazing things that they're offering to our industry. And we'll see you all again next week on Did You Know? The ESCO HVAC Show. Bye, everybody.
See you, everyone.